Hello and welcome back to Cracking the Cryptic. So I hope you caught Simon's live stream yesterday playing The Witness. If not, that you've maybe seen it in the video version, the VOD. I learn these new terms now. So that was good fun. We of course also have all kinds of stuff going on. Zeta Math's bonus puzzle hunt and new content coming out soon on Patreon as well. That'll be on the 1st of September. And of course, loads of stuff going on Discord. As always, our apps are all available. There's been an update to the Chess Sudoku app recently, so make sure you've caught that if you were waiting for that. And what are we going to do today? We're going to do 5 genuinely approachable Sudoku puzzles from the Gas series. So this is in the Daily Puzzle channel on Discord. Philip Newman, Sam Kappelman-Lyons and Clover produce a puzzle a day that is genuinely approachable, often a very good introduction to the various types of rule that we get in our variant Sudokus. And I'm really looking forward to these. Now, couple of innovations. One is you can see what date these are from now in the title. As you can see, well, when I take off the card, this is from August the 6th, and we'll be doing August the 6th through 10th today. And the tiny URL links, I've been using those a little bit occasionally, and they are very useful They do call up an enormous link at the top of the screen for you, but nonetheless, they have the puzzle in our software. They save some time and effort, and most importantly, risk of corruption in our creating the puzzles again in our software from scratch. So I'm very happy to use them, frankly. And I've called up the 5 folders, the 5 puzzles. 4 of the tabs took quite a while to load, so I don't even know what the markings on those pages are. I have no idea. I am going to go through them, rules one by one in order, just so we understand what I'm going to be rushing into. I am also going to be restarting each puzzle so I can see my clock, which is my kind of, I like to know what time I've done, just so I get an idea of how we're going. Not that we know what the necessary standard. Now, on the spreadsheet, which is accessible on the Daily Sudoku channel, that lists all the puzzles, you can, if you go into the cells, see the hidden times that award 2 hats for a fast solve and 1 hat for a medium fast solve. So I'll be aiming for those. Somebody's normally very kind and quickly tells me how many hats I got when I post the video, so I'll probably wait for that. So what have we got? We've got a Philip Newman puzzle for the first one. All of these, I'm sure, will be normal Sudoku rules apply unless there's an irregular. Along green lines, digits differ from their neighbours by at least 5. This is what we know as German whispers, which will be why Philip's called it shh. So any 2 cells connected on a green line have to have a difference of at least 5, which is quite a significant constraint. Then we are going to be doing, I've got my own Maverick version going on out there. You probably can't hear it, but I can. Sounds like a helicopter. Arrow by Clover, which is an arrow Sudoku. So digits along an arrow, which can include repeats, must sum up to the digit in the circle. Fair enough. Then, we've got, I hope you can see these arrows. I think you probably can. No, I'm gonna reformat this video before I start this puzzle before I start, so the arrows are a little larger. Actually, it's called Cupid Sudoku. For instance, there's an arrow here pointing down left. Actually, why don't I reformat that now and then carry on with this explanation? Hang on one sec. Right, so just a second for you, tiny bit longer for me, but here we go. We can see the arrows a bit more clearly. This is called Cupid Sudoku by Sam. Digits on an arrow must repeat at least once in the direction of the arrow. So if there is a 9 here, there must be a 9 also in one of those 3 cells. That's what that means. You can see that it's called Cupid because not only has it got arrows in it, But Sam has created a heart out of the givens, which is very pretty, very nice. Then on August 9th, Gas LXIV. Now, I don't know what this is, by Philip Newman. So, normal Sudoku 64, because this must be gas puzzle number 64. Oh, that's cool. Normal Sudoku rules apply. Digits in cells separated by an X must sum to 10, and digits in cells separated by a V must sum to 5. No negative constraints, so those two might sum to 5 or 10 as well. And then finally we have X sums by Clover. I like X sums. So the digits outside the grid, or the clues outside the grid, tell you the sum of the first X digits in that column or row, looking from that direction, given that the first digit is an X. So if we had a 2 here, that would mean the first 2 cells would add up to 9, and that would have to be a 7, for instance. That's how X sums work. They work on the first digit. That gives you the X that tells you how many digits the clue is adding. So relatively understandable, I hope, these ones. I certainly have done X sums and XVs before, and arrow Sudokus and German whispers. I might have done something like digits on an arrow must repeat at least once in the direction of the arrow. I certainly don't know of it being called Cupid Sudoku. But looking forward to all of these. Do give them a go on the links under the video. One of them now is not a tiny URL link. And I shall start now. Let's get cracking. Let's get cracking as we restart my clock. There we go, I remembered. Right. Now, German whispers. So 5 can never be on a line because it can't have a neighbour that is 5 or more away from it. So this has to be a 5, and this has to be a 5. And that means those two are 5s and not these two. Now we can maybe finish off 5s. Yes, we can. Very symmetrical puzzle, as one expects. I have a feeling this will be one where rotationally opposite digits always add to 10, but we may find different. Right, what next? Okay, there's no... 6s and 4s are hard to place. That's another important thing. Right, where in this box can there be a 4? Not there, for instance, because of that 4, but also not in any... Oh, maybe there. I was going to say, a 4 can only be placed where it can have a 9 on either side of it, on both sides of it. So I suppose 9 could be there. So one of those is a 4 and one of those is a 4. 6 over here has got to work exactly the same way. That could be a 6 and that could be a 6, but nothing else. And therefore, okay, this is now a 4-6 pair. 8, 5, 9. All see this cell. So if it was high, it has to be 6 or 7. This then has to be 1 or 2. It's not getting anything done. 1, 5, 3, 2. Okay, what about this? Where are 4 and 6 going to go in here? That's the question, right. They cannot go in any of these cells, I reckon, because they would be surrounded by 2 of the same digit, which is impossible. So 4 and 6 have to be there. 4 and 6, therefore, have to be here as well. That's an X-wing on 4s, and there's a 4 in one of those. So 4 in column 9 now has to be here. One of these two is a 4. I rather bet it's there, but that's not the way to do it. I suppose those two could... Well, that can't be a 4, but that could be. 4, 9, 4. Okay, something I could maybe have done more quickly is to mark all the alternate digits. So these are either, the ones I've marked are either high or low on this German whisper line. Right, so these can't be high because 9 and 6 are in the column. We've only got 7 and 8. So they are low. They are 1, 2 and 3. Right, so the oranges that I've marked are low. So this can't be 2 or 5. I don't know if this is going to be worth doing. Probably not. Yes, it is. Right, this is low. That's the important thing. That's 4. That's 6. This can't be 4. So there's a 1 in one of those. That can't be 1. This is 2 or 3. So these have to be from 7, 8, or 9. This, oh, it sees a 6. Yes, both of these see a 6, so they're 1s. Both of these see a 4, so they're 9s. That's how we go. So 8 and 7 are in those positions. I've got a 7, 8 pair and a 2, 3 pair. This is where 5 goes. I could have done that ages ago. 5, 1, 6. So small here, but it can't be 1 or 4. So that's made a 2, 3 pair. So over here, we have to fit in 1 of 8 or 9 and 1 and 7. So the high numbers are on the outside. So this side, these are the low numbers. So same color for low numbers. These are always low. So that one's a 4, surrounded by 9s. This one's a 6, surrounded by 1s. 8 in this row goes there. We've got a 2, 3 pair to deal with. This is a 6, 1 pair. They can go in thanks to that 1. We've got a 2, 3 pair here. I am conscious, though that has to be 8, that the orange colour is not the best colour I could have chosen. Let's go yellow instead of orange so we can see everything clearly. This is a, oh, maybe it's the green line that stops you seeing everything clearly, sorry. So that's not a 4. We've got a 7 or 8 here. In fact, it's a 7, so that's 8. 2, 3 X-wing that is going to be resolved because 3 can't be next to 7 there. We've got 1, 8 and 7 over this side, 1 amongst 7 and 8, 4, 9, 5. We've got 3, 2 and 6 to place. That is 2 or 3, but this there could be 7, 2, 8, 2 or 8, 3. Lots of possibilities. 8, 5. One of these is a 9. The other is a 7 because they're both high. So this is a 6, 4 pair. Right, so this must be a 4 with a 9 there. Okay, so that's 7. This is 2 or 3. Don't actually know which. 4, 5, 1. So we've got 7, 6 and 8. So that's 7 or 8. We can put 6 in there. I think that rule is still applying across the grid. That is 7. The rotation symmetricals adding up to 10. Oh, that's a 2. Right. 3 there. 2 there. 3 can't be next to 7, so it must be next to 8. That resolves this X-wing in the same way as on the other side. We've got 3 and 6 there. 3 can't be next to 8 here, so it's a 9. 7 and 8. 4, 6 and 9 to go in the top row like that. 6, 8, 2, 9, 5, 7, so 4. 1 and 3. That must be a 1 because it's next to a 6 on the line. 2, 8 and 7. Yes, they can go in. We've got 6 and 7 here. I don't like this. No, we haven't. We've got 2 and 7. That works better. 4 and 6 are resolved. 1, 8, 3 must be 3, 8, 1. And 2 and 3. Oh no, one more pair to go. 2 and 3. There we go. So just over 7 minutes for that. Took a little bit of a while to get into. I should have seen the logic in that a bit quicker, but that's an okay time. Right, we'll move on to Arrow by Clover. Digits, yes, with a, okay, we know how this works. We discussed it. Right. The long arrows are helpful. So they've got to be a 1 and a 2 there is the minimum, and 1, 2 and 3 there, and that adds up to 9, which is the maximum that can go in an arrow. So we can do that up here as well. 1, 2, 3 there. That's helped because these are all in one box. Now that relation doesn't apply, but these have to be at least 3, 4 now. So they are 3, 4 or 3, 5. They definitely include a 3. That is a 1 or a 2, and this is an 8 or a 9. So now we've got a 1, 2 pair. We've got a 1, 2, 3 triple. Is that working on this as well? No, we haven't got full symmetry. Okay, But these both see a 1 and a 2 as well. Yes, sorry, we have. This arrow works very similarly, at least. So 3 and 4, or 3 and 5 there. One of them is a 3. This is 1 or 2. This is 8 or 9, which forms a pair with that. These can't be 8 or 9, or 1 or 2, which are in the box. So they are 3, 4, 5, 6, or 7. Come on. It's going along very nicely. Now, that can't be a 1 or 2. No, that's not it. This can't be 1, 2, or 3. And that can't be 1, 2, or 3. Okay, the top one is seeing that triple, and the bottom one is... Oh, both of them are seeing that triple. Okay, so that's a 4, 5 pair with a 9 there. 9 there. So that makes this 8. That makes this 9. Now, 8 is the minimum. So we get 1 plus 3 and 4 there. 9 has a degree of freedom, but that's used up by that too. So again, we have 3 and 4 here. Come on, 1, 2, 3, 4, 5. We've got 9, 6, and 7 to place. So that is 6 or 7. Right, that has got to be 3. Oh, come on. 3 plus 6 equals 9. So that's not a 3, that's not a 3. This has become a 2. This is a 1. That's a 2. That's a 1. Those aren't 1s. These aren't 2s. I hit the wrong button. Right. 3 is looking at that cell. So 4, 3, 4, 3. These can't be 3s. That one can't be a 4. In fact, where does 4 go in column 6? Can't go here, because that would make that a 4 and clash with that. So 4 is there. This can't be 1, 2, or 3. It could be 4 or 5. So that's 8 or 9 as a result. 4, 5, 1, 2, 3. So this can't be 8 or 6 either. That is 9 or 7. But this has to be at least 5. So that's a 9. So that can be 5 or 6 as far as I can see. There must be a 1 here. So that's got to be here. This is 2 or 3. It can't be 3. So we're looking at 1, 2, and 6 up there. That has fixed this triple. 3, 1, 2. That probably looks across. Yes, 1, 3, 2. Still don't know what this is, but we've got 6, 7, and 8 to put in the row. Right, this one can't be a 7. In fact, that can't be a 1 or a 2, so that's 3 again. 6 there. Now we've got a 7, 8 pair. That's 7 or 8. This is a 9. And there's a 5, 6 pair. Yes, this can't be a 6, so that's 5 on that small arrow. 6 there. Let's look across. Yes, 5 and 4 are resolved, so that's a 5, 7, 8 and 4 here. Well, surely can't be 8 on the arrow, so it's 4 on the arrow. 9, 3, 4, 2, 1. Oh, that doesn't help with that. But one of these, no, this could be 2 and 3. No, that can't be a 2 or a 3 or a 4. So it's a 1. This can't be 1, 3, 5, 6. So it's 2 or 4. Oh, yeah, this is 7, therefore. Right, 2 there. That fixes these as 8. 7 here. Got 5 and 8. Can't do them. Oh, that's really weird. I can't do the columns. I thought they would all fall now. And they absolutely don't. Oh, I thought I'd finished. That's a naked single. Okay, so we can finish column 3. Let's try column 7. 2 must be there. 4, 7, and 6 to go. No, it's not obvious to me how. Right, 5, 7, 1, 9. 2 in column 1 is there. 4 is there. And this is a 3, 8, 6 triple. 4, 4. One of those is 4. 7 in this box must go there now. That's the way to look at it. So then we've got a 4, 6 pair that I have not resolved. 3 in the column. No, okay. 8 and 6 in row 7. There we go. We've got 5 and 6 down here. Yes, they are resolved. 6 there. 3, 8 pair. That's a 5, 9 pair. 4, 3 and 8. That is the bottom row done. This has become a 6. Don't look there. Finish off the columns that only have one cell left. And then we can finish off row 3 finally. 6, 1, 9, 2, 4. So we've got a 3, 7 pair at the top. 8, 5 below it. That allows us to do the 8, 3 pair at the bottom of the grid. Then over here we have 5, 1, 5, 9. Come back and there must be a 4, 9. There we go. So just under 7 minutes this time. I thought I was flying there, but obviously there was more to it than I was realizing. But it's a really nice puzzle. Definitely the break-in is on the really long arrows. But after that, you kind of have to work out what comes next. That was disappointingly slow. Anyway, we move on to the third puzzle, this Cupid one that I don't really know how to do. We'll restart it. Here we go. Maybe ordinary Sudoku. So that is 5, 8 or 9 because it sees everything else. Not very helpful that. 2, 3, 6, 5, 7, 1, 4, 8 or 9. So 2 of those numbers are seen on those. Okay, what's this? 1, 5, 7, 8, 9. So those 3 arrow cells must appear here, whatever they are. And that means 6 is not one of them, or 2. 6 also can't be there. So one of these is a 6. I don't know if that's actually any use. So again, these can't include 1 and 8. So these can't include 1 and 8 because those 3 cells must replicate up here. It's a bit like an anti-diagonal in that way. But that doesn't actually get much done because all of these can be 1 or 8. How about down here? Those can't be 3 and 4, nor can these. So 3 and 4 are confined in this area. I don't think I'm doing this the right way. There's not much point putting that in, but anyway. Okay, so 7 can't be in those cells and obviously not there either. 4, 4. Can that be a 4? Yes, if that's a 4. Otherwise, we've got a 4 here, but we could have 4s in those positions. That would give a 4 here. No, hang on, this can't be a 4 because it sees that. Right, sorry, this is just regular Sudoku and I'm being a fool. 4 goes in there. One of those is a 4. So these don't include 1, 8 and 4 now. That's the way in. So those can't include 1, 8 and 4. So these are 1, 8 and 4. These 3 cells. So 1, 8 or 4 there. Now that hasn't really changed. It has changed the population a bit. They're from, right, 4 is obviously not in those cells, so it can't be in one of these arrows either. So this is nearly a triple now. 6, 1, 5, 8, 9 can't, 3 of 1, 5, 8, 9 can't be in those, or are in those cells. Oh. So I thought I was coming out, if 1, 8, 4 are confined there, yes, that can't be 8. Oh, so 1, 8 is a pair that's coming in here. Good grief, why can't I see this? So 1, 8 are in those cells. So 8 is in one of those 2. 1 is in one of those 2. I don't quite know what to do with it. Oh, 1, 8's a pair. This has become a 4. Gosh, wake up. And if these can't be 1, 8, 4 and those are 1, 8, 4, 2, 6, 3, this triple is 5, 7, 9, and that has to be a 9. There we go. That really took a ridiculous amount of time. 3.5 minutes in. And I think that secret was available from the start. So actually 1 must be there. I can now see that. 8 there, 5 there. 8 is going to end up on this. No, 8 is in one of these, isn't it? That's what it means. Don't know which way that goes. That can't be a 4 now. Right. Those 3 don't include a 7. So those don't include a 7. Oh, sorry. These have become 7, 5, and 9. I'm so slow with this rule set because they're pointing up there. Okay. So 6 goes here. This is a 2, 3 pair. Now 2 and 6 are up here. We know where 6 is. Oh, this is just becoming almost straightforward. 7 can't be on the arrow because it can't end up in the triple here, which are 6, 8, and 9. In fact, 6 must be there and not in one of those two. And up here, this group has to be the same as this group. So there's a 4, that must be here. There's a 5 or a 9, that must be a 9 there. There's a 2 or a 3, which must be a 2 here. Okay, once you see how the rule set works, it's not too bad, but that really took a while. Let's fix the 1, 8 now. I've got 1, 5, and 3 to put in here. Let's put in the possibilities in each cell. 1, 3. Right, this is an 8 to finish the row. 4, 5, 6. That's a naked single 3. That resolves the triple down here. No need to mention chocolate teapots this time. It's very straightforward. 5 and 7. So lots of central boxes done. 4 in the row goes there. Column 8. No. Column. Row 2. That can be just filled in. 7, 9, 1, 4, 5. Where should I be looking next? Oh, 8 gets placed there. That's a naked single 3. We've got a 2, 6 pair. 1, 5, 9's a triple up there. We can do the 3, 2 pair below. Now, column 1, that's a naked single 8, flanked by 5 and 9. That is a naked single 6 in column 7. 5, 9, 8, 3, 9, 5, 6. I don't know what else to do. That's a naked single 2. How about that? So that fixes the 6, 2 at the top of the grid. We've got a 1, 4 pair there. 7, 3, 6 are right-ins at the bottom of column 3. That's 5 or 9. So we get an 8 down here. 5, 7, 9. There we go. Bottom row suddenly done. That's now a 9. That makes this a 5. We can finish that top row. Got a 3 and a 1 to put in there. We're going to be somewhere around 7 minutes yet again here. It's becoming a theme. There we go. 7 minutes 13 seconds it says. Slow start, quicker finish. Nice puzzle. Very clever. You could really nail that. And that's the sort of thing Tan would do in 1.5 minutes and just freak me out. Right, let's move on to, actually, let's have a drink of water. Getting a bit throaty here. Gas 64 in Roman numerals. Right, XV. So let's restart the clock. Here we go. So this is a 1, 3, 2, 4, 2 by 2 set here. Now that is 9, 8, or 6. This is not the way to do this at all, but 8 is nonsense there. That's 9, 7, or 6, as is that one. Again, there's a 1, 2, 3, 4 set there. Those can't be 4, so those can't be 1. They also can't be 2 because they're both connected by an X in a column with an 8. So we can take 3 out of there. This is now 8 or 9. Oh, that could never be 7, so that's not 3. So this is the 1, 4 pair. So that's 2 and 3. This is 4 and 1. We get a 9 there, 6 here, 7 at the top. That couldn't be a 6, never could be, so that's not a 4. In fact, we know these are 2 and 3 because we got the 1, 4 pair. So that's become a 7. Yes, we do know which way round they go thanks to the 9 on the left, which is also finishing off the box. That means we can finish off 5 and 8. 2 boxes done. This is clearly a 1, 9 pair. We get 4, 6. This is clearly a 2, 8 pair. Oh no, Philip's favourite symmetry trick is not actually happening here, although there is some sort of symmetry going on. That can't be 1, 9 or 3. Oh no, that's a 1, being C's 2, 3 and 4, and it's on a V. So we get that. This is now a 2, 3 pair in some order. Now again, we've got 1, 2, 3, 4 up here. That's the only place for 4. Slightly different, I like that. Slightly different logic to make progress up there. Now we've filled all I think, of the X and V cells. The rest is classic. So where's the best place to start? Naked single. Often the best place to start if you can spot it. What does that do for us? It puts a 6 there, actually. We might be able to finish. No, we can't finish 6s. 2, 3, 4, 6, 7. That is a naked single as well. So there is some symmetry going on with those. Oh, there's a weird X-wing of 8s and 9s in rows 3 and 7 now. 2 in column 1 is there. Come on, how do we get up into rows 1 and 2, rows 8 and 9? That's going to be absolutely key to this puzzle. 6, right, that's a 3, 4 pair. Okay, so they're done. That's a 1, 2 pair that are not done. 7 must be here. This is an 8, 9 pair. All of these are 8 or 9. So that's a 4. 4, 3, 7, 6, 1, 2. Don't know there. 2, 3, 4, 2, 4, 6, 7, 3. That's a 9. Oh, that was never an 8, 9 X-wing because there was a given 8 that resolved it that I just couldn't see. My apologies, folks. That is a naked single. 9. 1, 5 pair there. Still don't know what that is. 5, 9 up here. Right, 9 in this column is there. That fixes the 5, 9. Doesn't fix this 1, 5, but I can do the 7, 8. 2, 6, 4. That's a naked single 3. That's a naked single 1. So that does all these 1s and 5s. We get a 9 there. This must be a 1 to finish the column. It also deals with the other pencil marks we had, and we get a 7, 3. This must be 6. 2, 6 at the top, and 5 and 8 below. That must be better than 7 minutes. There we go. 4 minutes, 10 seconds. I mean, it's a nice puzzle, but it does unfold very clearly if you start, as so often, with these patches of V's that were delineated there to give you where 1, 2, 3 and 4 had to be. Right, and a 5th puzzle. So August the 10th we get up to. I still seem to be going backwards in time, no matter how many of these I do. But anyway, here we go. This is X sums. Right, so a 3. That has to start with a 2 and have a 1 there. That has to be right. Right, 39 is missing 6 in total because of the 45 secret. So we get a 3 there. 45 always gets a 9. 6, can that be 2 or 3? 10, and it can't be 2. It could be a 4, but otherwise it's a 3. 42 here. So if that was a 7, this could end 1, 2, but that would make a liar of the 6 clue. So that is a 6. It ends, therefore, in a 1, 2, 3 triple. So they add up to 6. That's a 3. That's a 2-1 pair. So I should have really been spotting where just the fact that they added up to 45 was useful. So we get a 6 by Sudoku in the top there. Oh, and that petered out quickly. Right, 36 and 15 have an overlap of 6. So the 36 could be 6 or 7 cells. Could even be 8. But then there'd be a 9 on the end, so that's not possible. If it's 6 cells, these 3 add up to 9. That would have to be a 4, and that would be the 6. But then that couldn't be a 6, so no. It can't be 6 cells, it's 7 cells. These 2 add up to 9, but they're going to need 6 more to get to the 15 total. I'm not even going to fill in 4 because that could be a 5 as far as I can see. These 2 add up to 9, so that is also 4 or 5. Well then to make up 6 without using a single 6, it's got to be 3, 2 and 1, so this does start with a 5. That doesn't resolve this blinking clue. Right, 20 along here can't be 5 or 6, so now it must be 4 or 3, and that's a pair. Oh, 28 can't possibly be a 3. What am I talking about? In fact, it can't even be a 4, can it? How is 4 plus 6 would need 18 there? Oh my goodness, I've done something wrong. That is... Yes, this said 42, not 43. That is a 7. Oh, crikey, I don't know how much this might have messed up. I don't think all that much. Those 2 have to add up to 3. No, that's an 8. That's a 3. I did my maths wrong. But I think I'm fixed. I think... Right, this is a 4 because 10 and 28 just can't share any other digit. That's what. That's the break-in that I didn't spot at all. 9, 7 there. Okay, this is working now if I haven't made other mistakes. No reason why I should have, but no reason why I shouldn't as well. We get a 7 must be there, 4 must be there, 2 and 1 and 6. So 20, that's done. This 24, I don't know, 2. It gets us a 7 there. I think that was the example I gave. Should have been on the alert for that. 7 there and a 5, 8 pair. That has to be a 5 out of those. So 5, 1, 2, 3, 4 down here. That's got to be a 4. 1, 2, 8, 6. 2 is there. That's a 4, a naked single. We got a 1, 5 pair here. 4 and 7, well that can't be 7 for any number of reasons. That now must be 9 to be max. Oh, lovely puzzle, lovely. It doesn't stop it being a lovely puzzle because I made a foul mistake on it. 4, 3, 1 to finish the row, 4 to finish the box, 3, 8 and 5. Now, no, we've used the clues. We've used all the clues, I think. So the rest is classicness. Right, that's a naked single 2. 1 there. 3 and 1. That's the wrong cell. Let's go back. That's where I was trying to put a 1. 9 and 3. 7 and 2. Yes, we can do those. 9, 6, 8 along here. Surely that is susceptible. Actually, not entirely. 1, 5 and 6 down here. So 1, 6, 5. That's 3 and 8. That does fix the 9, 8 pair. Oh yes, the 1, 2 pair has been fixed. So we can do 1 and 5. Must be a 5 to fill in there. And a 9. 7 and 8. Sorry about the bonehead mistake with the 42 clue. There we go. It's 5:48. I mean, probably I could take a minute off if I wasn't having to faff around fixing that row. Thank goodness that getting this end of it wrong because of that end of it. I didn't really. I got it right. I don't know how. Yeah, I was, for some reason, maybe because I'd seen this 39 clue, I was imagining that this total was 45 minus 6, which is really the poorest arithmetic one can imagine. But there we go. 5 brilliant puzzles done. I mean, they are really good. 777, well, 7 something, slightly less than 7 something, 4 something and 5 something. It's not bad. I'm happy enough with that. Really nice puzzles. Thanks so much, as always, to Philip, Clover and Sam for their brilliant efforts. And really intriguing. Thank you very much for watching, as always, and hope to see you soon on the channel. Bye for now.